Hey everyone, welcome to your play posit for the day. We're going to be going over lessons 5.02 and 5.03 from your OMHS. We're getting into Unit 5. Go ahead and grab your notes, whether you printed the guided notes I provided or you have your notebook paper. Have your OMHS play posit graded assignment open, and let's get started. So, quick reminder, you guys may have seen this in the newsletter from the week before we left for fall break, but we have a Wonderland of Gingerbread assembly coming up. I'm so excited. The seventh grade assembly, I don't think I have any seventh graders this year in geometry. So most of you are eighth graders. It's going to be Friday, December 11th at 1 o'clock. And so if you guys would like to participate, you have two options. One, you can create your own gingerbread creation. You can use any materials that you like. You could do the traditional graham crackers or gingerbread. They have kits at the store, or you can go off the grid and you can do. I saw someone last year did one with cheeses like cheese sticks and cream cheese and crackers and salami. It was so awesome. And I think I'm going to make mine this year out of Pop Tarts. I saw this YouTube video on that. So you can do anything. Excuse me. You can even do like a drawing if for some reason you don't have the materials on hand and you want to participate. You can design your own gingerbread creation that way. And you can submit your photos and descriptions of your creations in a Google form that we have for you. I can't give you this link right now through a play posit, or maybe I can. I'm going to try. But if not, always go back to your newsletter, grab the link to do your submissions. Teachers are going to be reminding you about this in class. They'll give you the link. It'll be in your geometry plan. I'll have the link there. You can email me. And we want all those submissions by December 7th so we can get them ready for the 11th. And if for some reason you don't want to make a creation or you don't have the supplies, you can still come to the assembly and see what your classmates created. And we're going to have a winner for two different categories. So you guys can vote on those winners. We'll have prizes. It's going to be fun. So today we're going to be looking at actually not going to be doing coordinate plane information here. Sorry about that. I needed to update this. We're going to be looking at parallel lines and transversals. Transversals. So look at this cat geometry. So cute. Before we do that, let's just review a little bit from what we went over before fall break. So here's the first example. It says, prove that line L is parallel to line M. Before I go much further, don't forget, you guys, whether you're watching the play posit or you're watching the view pure link, you guys can pause at any time, whether you need to catch up on your notes or you want to try the examples on your own. So don't forget that. So what does it mean for two lines to be parallel? Well, we can look at this picture and see that they're parallel, right? They're not intersecting, but it's more specific than that. Parallel lines have the same slopes. They have equal slopes. So in order to prove that the lines are parallel, let's just show that the slopes are the same. So we can find the slope of L. We'll go down 1 over 1, 2, 3. Down 1 over 3. So the slope of L is down 1 over 3. I did a negative 1 since we went down. Ideally, line M should be the same. If it is, then we've proven that they are parallel. Let's see. Down 1 over 3. Yep. Down 1 over 3. Awesome. So the slope of line, this is funny. I would never do that. Who made this problem? The slope of line M is also negative 1/3. That's hilarious. They used M for the line. Hilarious. All right, let's look at example 2. Which statement describes the lines whose equations are? So this time they give us the equations of the lines instead of the pictures. We kind of have two options here. We could graph the lines in Desmos and see what they're doing. We could also look at this algebraically. So let's try to get this second line into y equals so we can see what the slope is. Remember, the slope is the number that's in front of the x term when it's in slope-intercept form. So we got to get the y by itself. So to get this y by itself, we just need to divide everything by 6. And we're going to get, so 2 6, that reduces to 1/3, right? 2 goes into 2 one time, and 2 goes into 6 3 times. And 6 over 6 is 1. There we go. There's our line. Here's our slope this time. And it wants us to tell them whether the lines are, basically, are they parallel, perpendicular, or neither? You can see the options here. Perpendicular, they intersect, they're parallel. So if you look at these slopes, they are exactly opposite reciprocals. They are opposite, meaning this one is negative, this one's positive, and they're reciprocals because they're flipped. If this is over 1, we flip it and we get 1/3. So they are perpendicular to each other. Again, you could take both of these and put them into Desmos and graph them and confirm that that is the case. Well, at least you would definitely see they're not parallel because they would be intersecting somehow. So it'd either be B or C, but once you look at the slopes, you'd see that they are exactly opposite reciprocals, so they are perpendicular. All right, we're going to be, again, I think I mentioned this earlier, looking at parallel lines and all the different angles that are formed when you start intersecting them with other lines. So this is a really cool architectural design picture. This is a real picture. Look, there's real people. You can't see that. Real human people. And you can see all these different angles that start to form when you start to make intersections of lines. It's really cool. So I do have a Desmos activity for you. I'm going to put this link into the PlayPosit question so that pops up. You guys can click on that. If for some reason you're not able to watch the PlayPosit, then I'm going to also have this link in your graded assignment. You could go to that and click it. And I want you guys to work through this. It's going to basically sort of just, you're going to discover what happens and what kind of angles are formed. And then we are going to talk about this a little bit in live class together. So I'll be able to see what work you completed and we'll share some of those outcomes. But go ahead and do this before you move on. All right, so here's our first slide with our definition of what is a transversal. So this is basically a fancy word or fancy term for the name of a line that intersects any two lines at specific points. So the formal definition is basically here. We could say it's a line that intersects two or more other lines at distinct points. So it's not going to be directly on top of it. You can see this is transversal T in our example, and it is intersecting line M and N here and here, two very distinct points. And it's more than one line. So we would not say M is a transversal. M is not a transversal because in this particular diagram, although we're not sure what's happening over here, this particular diagram, M is only intersecting one line. So T is our transversal. When you have a transversal, lots of things happen. They form 8 different pairs of angles. And in that Desmos activity, you guys saw what happens and you saw those different angles, and we're going to give those angles some names and we're going to talk about them. These are all of them. We're going to talk about each of them individually and then look at some examples. So the first ones we're going to talk about are vertical angles and linear pairs. So these angles are not new. We know what vertical angles are. Vertical angles are angles that are directly across from each other. And they share a vertex. Remember? They share a vertex. Oh, the most important thing, I think, they are always equal. They are congruent. So if we look in this picture, some examples of vertical angles would be angle 1 and angle 4. See, they are directly across from each other. They share this vertex here. They are congruent. Angle 1 is congruent to angle 4. This is an example of a vertical angle pair. Let's see. Here's another vertical angle pair, 2 and 3. Angle 2 is congruent to angle 3. Sometimes we write it like this, angle 2 and angle 3, like a pair just listed. Those are vertical angles. The second one here on the screen, linear pair. So we looked at these as well. A linear pair are two angles, right? A pair, meaning two angles that are on the same line and they share a side. And remember, these angles are always supplementary. Remember what supplementary means? It adds up to 180 degrees. So if we look at our diagram over here, some examples of linear pairs. Here's one, 5 and 6. See, they're on the same line and they share this side. So those two angles, 5 and 6, are a linear pair and they add up to 180 degrees. So you could write angle 5 plus angle 6 equals 180. Or you could just list them out. Let's see, another example of a linear pair would be even this way, 6 and 8 this way. They're on the same line here and they share the same side here. So angle 6 and angle 8 are another example. You can see in this diagram there are tons, right? 1 and 2, 2 and 4, 3 and 4, 1 and 3, anything that are on the same line that share a side, they're going to add up to 180. All right, moving right along. This is kind of like the first new kind of angle pair, since we already knew about vertical and linear pairs. We have corresponding angles. So if two things are corresponding, they are angles in the same position. Angles in the same position, and I'll show you what I mean. Here's an example, like angle 1 and angle 5 are corresponding. See how the 1 is up here, the top left? I'll call this the top left because this transversal hitting line M basically makes 4 angles, right? 1, 2, 3, 4, kind of like a coordinate plane. And then this line L, there are also 4 angles. So angle 1, sometimes the way I kind of talk about it, I'll say it's in the upper left position, right? And angle 2 is in the upper right. 4 is the lower right. So sometimes that's just Miss Winslow talk. So angle 1 is in the upper left of this parallel line, and angle 5 is also in the upper left of this grouping. So you guys see how they're in the same position? They're both in the same upper left quadrant, if you will. So they are corresponding. They correspond to each other. Let's find another pair. Angle 4 and angle 8. Hopefully you see the color coding too. Angle 4 is in the lower right-hand position, and angle 8 is also in the lower right-hand position. So that's another example. We have more, right? 2 and 6, they're both in the upper right position. And lastly, 3 and 7. And the special thing about these angles, which you probably learned in that Desmos activity, is they are congruent. They are equal, they're congruent, they're the same measure. So if angle 1 is 101 degrees, you automatically know angle 5 is also 101 degrees. They also look congruent, right? I mean, if you kind of had to guess, if you looked at that one and you looked at that one, you're like, yeah, those look the same. And they are. That's their special property. They're congruent. All right, our next pair of angles are called consecutive angles. So when you guys think of the word consecutive, what do you think of? I don't know why I always thought of consecutive integers, like 1, 2, 3, 4. So consecutive numbers are numbers that come one after another. They're like right next to each other, right? So consecutive angles are kind of the same. So consecutive interior are angles that are on the same side. Angles on the same side of the transversal. Now these are interior, so these ones are on the inside of the parallel lines. Remember that's that symbol for parallel. I'm going to erase that bottom. I don't want you to think I mean perpendicular. Parallel. So here's some examples. Angle 3 and angle 5. These are consecutive interior. They're on the inside, so they're interior. And see how they're right next to each other? Like if you were walking on this line, you would hit angle 3 and then angle 5. They're sort of stacked. They're right on top of each other or next to, depending on how you look at it. If you were sort of to turn this diagram, they would be next to each other, right? So these are consecutive interior. They're inside and they're one after another. Another pair would be 4 and 6. All right, so then we have consecutive exterior. I'm guessing you can realize what this is. It's the exact same thing, except they are on the outside. So angles on the same, whoa, hold on. I have no idea what my hand just wrote there. Angles on the same side of the transversal outside the parallel lines. So here's our transversal T. It's cutting those parallel lines. And you can see angle 1 and angle 7, they're on the same side of it, the left side. And they're one after another on the exterior. So the outside of the parallel lines are up here. You can kind of think of that as like outside the house, right? And this is inside the lines. And the more you guys work with these, as with anything, you're going to get more comfortable with it. So I know this seems like a lot of vocabulary, so to speak, but as we start to work with them, you're going to get it. I know you will. So one pair is angle 1 and angle 7. And then you see we have another pair, angle 2 and angle 8. They are on the outside of the parallel lines, and they are on the same side of the transversal. And if you look at these, they don't really look congruent, do they? Like angle 2 looks pretty tiny, definitely less than 90, and angle 8 is definitely bigger. So they're not equal. These are supplementary. So that's the helpful special thing about consecutive angles is they are supplementary. Okay, yep, this is our last pair of angles, alternate angles. So let's just talk about it because I think you're going to be able to tell this one. Alternate interior angles, they alternate across the transversal. So remember consecutive, we're on the same side of the transversal. Alternate, they're one's on one side, one's on the other. Here's an example. 3 and 6. See how they alternate across that transversal? And we're talking about interior, so that means the same thing as it did before, inside the parallel lines. So our first pair of alternate interior angles, remember interior is on the inside, I'll make that green. Woo. Inside the parallel lines is the interior. Looks like a sandwich, like an ice cream sandwich, and you're cutting it with a knife. And then the exterior is going to be outside those parallel lines. So our first pair of interior are the ones I circled, angle 3 and angle 6. Oh my. And then angle 4 and 5, right? Those are alternating and they are on the inside. 4 and 5. Did I say 3? Angle 4 and 5. So alternate exteriors, again, the same thing, except they are on the outside of the parallel lines. So here we have angle 1 and angle 8. They're alternating. 1 is on the left, 8 is on the right. And angle 2 and angle 7. Now the cool thing about these angles is they are congruent. So hopefully you've seen that the angles are either congruent or supplementary, one or the other. So let's make a handy chart about that. Congruent angles, we can think of all the kind of angles that are congruent that we talked about. The first pair I can think of is vertical angles are congruent. And let's just go down the list. The next one was linear pair is supplementary, right? And then we might need to go back. Let's go back and look. Vertical angles and linear pair, those are the ones we talked about. Next, corresponding angles. Corresponding are congruent. Whoops, I lost my page. Where does it go? Here it is. Corresponding angles are congruent. And then we had, next was, I believe, consecutive interior and exterior. Yeah, and these were supplementary. Consecutive angles are supplementary, whether they're interior or exterior. And lastly, we had the alternate angles are congruent. So I'm not going to ask you to fill out a chart like this in the future. Like I said, as we get to working with them, it's just going to start to sort of become second nature. So this type of chart won't be like a question you'll be asked, but I thought it might be helpful for some of you guys who like to organize your thoughts that way. So let's practice. So here, the ones and the twos, those are angle labels, and the values with the little degree symbol, that's an actual angle measure. So they want us to find the measure of angle 1 and the measure of angle 2. So this is what I mean. You don't really, I mean, yes, we do need to know the names of them, but to solve this question, you don't have to know the names of them, right? We just need to know how they work. So 120 and angle 2, you kind of always have to start with what you're given. We only know that angle measure. That's the only one. So that's where we have to start. And you can work your way through the picture. So it's kind of up to you what you remember first. Some people will immediately think, oh, these are corresponding. Look, 120 is in the top left position, and so is angle 2 in this grouping, if you will. So they're both in the same position, so those are corresponding, so we know they're equal. Next, we have to find angle 1. Get a different color. Again, we can only work with what we have. And again, there's two ways to do this. You might say, oh, look, these are vertical angles, so I know that they're equal. Or check this out. This angle and this angle are alternating exterior. They're equal. So you can go straight from this 120 to this 120, or sort of work your way through the picture. Some people last year even said, well, if this is 120, I know this is 120, right? Because they're vertical. And then check this out. This angle and this angle are alternating interior. So I know they're equal. So they kind of worked their way through the picture. You only have two options. Are they equal or are they supplementary? Most of the time you can kind of figure that out too just by looking at it. Like angle 120 and angle 2, they look equal. They look like they have the same measure. Let's try question 2. Here's the 60 degrees. That's where we have to start. And then I would naturally go to the 1 because these are alternating interior. They're on either side of that transversal. 60's on the right, angle 1's on the left, and they're inside the parallel lines. These are alternating interior. They're equal. They look equal. And then check this out. We have a linear pair now. Angle 1 and angle 2 are on a straight line, and they share this side, so we know they add up to 180. So angle 2 happens to be 120 degrees. And we're done. You could also find angle 2 by saying, oh, this is 60. These are consecutive interior. They're both inside the parallel lines, and they're kind of one after another. Boom, boom. They're supplementary. All right, then you're going to have problems like this, where you look at it and you feel like you can't do it, right? Your brain starts to hurt immediately before you've even read the problem, and you feel like giving up. And I'm here to tell you, don't do it. I believe in you. I know that you guys can answer these questions, and we're going to take it one step at a time. It tells us in the example that AB is parallel to CD. Okay, so these lines are parallel. They look parallel. They're not intersecting. Then they tell us S is parallel to T also. So these lines are also parallel. So we basically have two sets of parallel lines. Find the measure of all the angles when angle 1 is 100. So let's label angle 1 100. That's all we know. And they want us to find all the other angle measures. So let's start working our way through the picture. Angle 1 and angle 3, this is what I would naturally do. They're vertical, right? What else is 100? Ooh, angle 5 is 100. Those are alternating interior. And also angle 7, right? Another vertical. So we already have 4 angles. Now remember, if it's not equal, it's supplementary, one or the other. So we can very easily now find angle 2. These are a linear pair. They add up to 180, so this has to be 80. Yeah, I'll keep working through that picture. Look, here's a vertical angle. This is also 80. Here's my alternate interior to the 80. It's also 80. Another vertical, and it's 80. That's it. Isn't that cool? Once you know one angle, you can find them all. Now, it does want us to continue finding the angles, and this is where visually it can kind of seem a little funky because you do have to sort of turn the picture to see it the same way. So like 80, I'm sorry, angle 2, let me get a different color. Angle 2 and angle 10, those are corresponding, right, in the same position. So this is also 80. And hopefully you can kind of see it unfolding, right? This is 80, 80. I'm just doing alternating. Here's another vertical. And then of course, I know that you could guess the other angle is 100, right? Because these add up to 180. And this is all because of the special properties of parallel lines and transversals. It makes sense if you think about it, right? Because the lines are parallel, which means they have the same slope. So whenever you cut a transversal through that line, it's going to form the same angle measures. And we're done. See, something that maybe looked crazy complicated to start, as you start working yourself through the diagram, it's not so bad. A lot of people mostly have trouble with remembering the names of the angles versus like the actual properties. All right, here's 3 more examples. And I have the same diagram for each one just so you could write on it. So this time they tell us some angle measures. Angle 3 is 4x plus 6. This is really tiny, sorry. That's 4x plus 6. And angle 11, where's angle 11? Oh, right here, is 126. Okay, find x. So these angles, look, they're in the same position on those transversals. See that? Bottom right, bottom right. So we know they're equal. So set them equal. Angle 3 equals angle 11, so set them equal and solve for x. Right? If this is a plus 6, we're going to do the inverse operation. And we get 4x equals 120. And then the inverse of multiplication is division. So you get x equals, you're welcome to use your calculator. I'm going to try this by hand. 4 into 12 is 3, so 30. X is 30. Okay, let's try number 2. So angle 1 is 100, ooh, just like in the last example. And they say angle 8 is 2x plus 10. Where's angle 8? It's so tiny. It's up here. Aha, these are also corresponding. They're both in that top left position. So they are also equal. 100 equals 2x plus 10. We'll do the same thing. Inverse of plus is minus. And you get 190 equals 2x. And then we'll divide. X is 80. Nope. Hold on. Ah, 2 into 190. I don't know. I think I thought that was 160. So this will be a 9. This is good old fashioned long division, right? And a 5. So it is 95. You can also use your Desmos calculator to divide that. All right, our last one. Let me get a different color. Something totally different. Green would be great. Y, okay, let's find Y this time. Angle 11 is 3y minus 5. And angle 16 is 2y plus 20. Okay, so when you guys look at these angles, do they look equal? This bigger one and this littler one? I mean, no, right? Right? This angle down here, angle 16, is super tiny. It's so squished. And the other one is bigger. So we know they're not equal. So if they're not equal, what are they? They're supplementary, right? It's either equal or supplementary. So if they're supplementary, then they add up to 180. So let's go ahead and add them up to 180. And when I say add them up, I mean just take them. This plus this equals 180. Let's solve for y. 3y plus 2y, we're going to combine like terms. That's 5y. And then negative 5 plus 20, that's plus 15. Now we're kind of exactly where we were with all the other ones, a one or a two-step equation. The inverse of addition is subtraction. And we end up with 5y equals, what is this? 165? Yep, and then we'll divide by 5. Huh. 33. Y is 33. All right, you guys, that was fun. I hope that you had fun. I hope that it makes sense. And we're going to go over a little bit of the Desmos activity on Thursday, so make sure you do complete that. Coming up is our live class. Yay. Haven't seen you in about forever on Thursday. And then Friday, we're going to talk about this more on Thursday, but we're going to start some small group reviews. We had our first benchmark test in USA Test Prep, right, shortly before break, and we're going to start using that data to have some small group review. So everyone, whether you see it now or later, you'll start to see some small groups on your schedule pop up. If for some reason you cannot attend them live, then just let me know and you'll be able to watch that recording. Otherwise, you are required to come to these sessions. So Ms. Jadala, who's awesome, is going to be holding those small group sessions. Remember, she's our math support specialist. So she's another math teacher that helps all the other math teachers out. Again, she's awesome. You'll love her. And as always, you guys, if you have any questions, please reach out to me and I'll see you on Thursday. Bye, everybody.